This solenoid can act as an inductance. If there is a current, an alternating current goes through this coil, then there will be, because of the flow of the current, there will be a flux which will keep increasing. So we know since the current is changing, the flux is also changing, so there will be an induced voltage, as we saw from Faraday's law of induction. So the induced voltage will be as such, so that it opposes the change and opposes the cause and opposes the change in flux. So the flux is increasing in one direction, so increasing current, the induced voltage will try to oppose that change, or will try to reduce the current. So it will try to produce a flux in the opposite direction, so it will try to produce a current in the opposite direction as a result. So the voltage will be, the induced voltage will be, as we know, it will be number of turns d phi over dt. This is coming from Faraday's law of induction. Now we can get rid of this sign, because essentially the voltage will be in that direction, so it will try to give a current in the opposite direction, so that it produces the flux in the opposite direction, or rather it opposes the increasing flux in the in the direction that this current is producing. So we can get rid of that sign, and this one is the induced voltage, which is, we can say, now we will define inductance. So this one is the voltage that is produced here, and this is the voltage of inductance. Now there is another term which we defined, which is the term L, which is the inductance of this solenoid. So that one is, instead of writing in terms of flux, what we write is changing current, the rate of change of current rather. So what inductance does is, we know that it opposes the change of current, and that's what we see why it happens, because the inductive voltage is produced by a current which is, so it tries to oppose that current. So the current that is causing the voltage there is actually being opposed by the voltage, the inductive voltage. That's why in an inductive circuit or an inductive element, the current lags the voltage, because inductance doesn't allow the current to change instantaneously. That's what we know. So we can equate these two to find, we can see that L is actually N d phi over di. So this is the inductance. And for a solenoid, the inductance can be found, it is given by an expression, I won't derive it. So this is permeability, then turn square, then cross section over length. So this is independent of current. This is the property of an inductance, of an inductor. So we can see this is the material property, permeability. Permeability is this one, so relative permeability times the permeability of air, then number of turns square, so as many number of turns, more inductance. Then this is the cross section, so the cross section here, and over length of the coil, so length of the solenoid. So this is how we can find the inductance of a solenoid. And yeah, this is just the basic property of inductance. And we know in an inductive circuit the current cannot change. So if we have something like this, let's say a switch there, so maybe the switch is closed now, and an inductance there. If suddenly the switch is closed, what will happen is, theoretically the current has to stop immediately, but an inductance will not allow that to happen. So what will happen, there will be huge spark here, and the current will still continue to flow, because just like capacitance, across a capacitance the voltage cannot change instantaneously. Similarly, through an inductance the current cannot change instantaneously, and the reason is the same thing, that it opposes the change of the current, and how much it opposes, how strong is the opposition, is depending on the value of inductance. The more inductance, the opposition is more, and the current will be driven for long. So this is how it is. Sorry, I wanted to say, if the switch is opened suddenly, that means it becomes an open circuit, then what happens? And also, when I was saying flux, I obviously meant magnetic flux. I didn't use the word magnetic, but it's magnetic flux because we are talking about a magnetic property that arises from changing current in a coil as given by Faraday's law of induction.